Coral reefs are very valuable resources economically, culturally, and ecologically, and they're based on the ability to persist over time through the processes of reproduction and recruitment. Here we see corals which are both male and female in characteristics, that is, they're hermaphrodites. The term comes from Greek mythology, Hermes, the messenger god, and Aphrodite, the goddess of beauty. These corals are releasing combined clusters of both egg and sperm that are wrapped around are the egg, and the white that you can see in the first polyp is in fact the sperm. And in this case, the corals are combining the two together. The eggs will float to the surface because they're full of fat, and they'll take the sperm with them. This occurs usually 7 to 10 days after the June and July full moons in the islands of Micronesia. But not all corals are hermaphroditic. Some, in fact, are separate sexes, like this polyp here, which is from a male colony, and as we watch it begin to contract, it's releasing a sperm body. Here's a case of another hermaphroditic coral. You can see the white part of the sperm there. This is a little bit different packaging where the eggs are actually embedded rather than wrapping up a sperm parcel. But again, the lipid fat in the eggs will enable these to rise to the surface. Well, they'll stay intact for about 20 minutes, after which point they'll literally explode, allowing the sperm and the eggs to interact. And what we found is that they really need to be from the same species, and also they need to be from different colonies, meaning that sperm from the same colony as the eggs usually won't fertilize them. Here we see continuation of spawning. In this case, we see individual eggs that are released. This is a female colony, and it's only releasing egg. These colonies here are back to the hermaphroditic species, releasing these clusters which float to the surface, where they'll remain for periods of 10, 15, 20 minutes, after which point they begin to dissociate, or in some cases literally explode, allowing the tiny eggs and sperm to interact. If an egg gets fertilized, it goes through a developmental cycle, and within a few hours it begins to develop small swimming hairs called cilia, which enable it to begin to swim around. Anywhere between 18 hours to about 72 hours, they move to the bottom where they begin to search, and they're looking for particular chemical cues that are often associated with material called crustose coralline algae. This indicates it's a good place to settle, and if they find the good stuff, they will metamorphose just like a caterpillar into a butterfly. These individual round bodies begin to cement themselves to the surface and undergo metamorphosis from the larval stage into the polyp stage. As the animal continues to grow, the polyps begin to differentiate. We'll see additional mouths form, and this is where colonies of coral actually come from. Here we see multiple polyps. Some were actually from different larvae that settled, and as we track these over periods from days to weeks, they increase in size to the size of maybe a dime or a quarter, and over a period of a year to 2 years, they get to the size where they too can reproduce. The critical issues for coral reef reproduction and recruitment is water quality and bottom quality, enabling the corals to synchronize, for the egg and sperm to interact, for the coral larvae to settle and metamorphose, and if all goes well, then we have the next generation of corals to replace those that die.